Okay, so this morning I'm going to walk us through how to complete some matching law equations. So give me just a second and I will share my screen and we'll get started. So I have written here the proportional matching equation. So when you're using this equation, it means that you had multiple response options, in this case 2, and you're looking at the proportion of responding that was allocated to a particular response option. So you're always going to have a target, and that target response option will be labeled B sub A. So that would be the response rate for your target response option. Which one you have as your target is not necessarily significant. It won't always be the one with denser reinforcement or anything like that. It's just whichever one you're interested in studying. So if we were looking at this in a clinical setting, the target response might be responding on like work completion, whereas there are other reinforcement sources available too, like talking out of turn and things like that. So your target is just going to be whatever you're most interested in knowing more about. So for our first example, and these are all using variable interval schedules because that's the best schedule to study choice and matching and look at that. So we've got variable interval schedules. In our first example, response option A is going to be a variable interval schedule 12 minutes. And then B is going to be a variable interval schedule 2 minutes. When option A is in place, the responses are usually 22 responses per hour. And when option B is in place, responses are 150 per hour. So in order to fill out this equation, we already have our responses per hour. So we've got our rate side of things, but we still need our reinforcement rate. So to calculate reinforcement rate, in this case, we're going to look at the idealized responding. So if the organism responded in a way that accessed all reinforcers, then how many reinforcers would be delivered. So to do that, we're going to take 60 minutes, since we're going with a total unit of an hour as shown from our response rate. We're going to take our 60 minutes and divide by our schedule value. So our schedule value for response option A is 12. So let me whip out my calculator so I don't make any silly math errors. 60 divided by 12 is 5. So in an ideal world, the organism would respond and would receive 5 reinforcers per hour. That's going to vary a tiny bit because keep in mind our variable interval schedule, each interval averages out to 12 minutes as opposed to being explicitly that. But this is going to be a close approximation of what we would have and an average over time. So for response option B, we're going to do that same thing. So we're going to take our total 60 minutes in an hour and divide that by 2. Probably could have done that one in my head, huh? So that would be 30 reinforcers per hour. So option B in this case actually results in more reinforcers per hour and larger responses per hour, more responses per hour. So prediction, we can think about which response option we think the organism will allocate responding to. But let's calculate it just to make sure. I like to do one section of the equation at a time, so I will start with this response rate side of the equation. And for each side of the equation, there are a few steps that I would go through. So step 1 would be to sub out the variables, substitute variables. Step 2 would be to divide with or complete what's in the parentheses. And then lastly, step 3 is to do the division. So when I'm filling out this side of the equation, the first thing I'm going to do is to substitute those variables. So I want the response rate for option A, which is 22 responses per hour, divided by, again, the response rate for option A. So again, 22 per hour, plus the response rate for option B, which is 150 responses per hour. So that's my step 1. It's already completed. Next step, complete what's in the parentheses. So that we'll keep our 22, carry that down, but we will complete the parentheses, 22 plus 150, and that's going to be 172. And then lastly, we will divide. So now I'm actually going to take that 22 and divide it by 172. So that's 0.127. So we'll say 1.3 and use our standard rounding rules. So now we have a value for that side of the equation. So next we can solve for the other side of the equation, the reinforcement rate side. The steps on this side are going to be the same. So subvariables, parentheses, and lastly, divide. So when we're substituting our variables, in this case, our reinforcement rate for option A is going to be 5 reinforcers per hour divided by the sum of the reinforcement rates for option A and B. So 5 plus 30. To complete what is in the parentheses, 5 divided by 5 plus 30 is 35. And we will do that. Five divided by 35 is 0.1428. So we'll round 0.14. So if we were to look at this equation side by side, it would be 0.13 equals 0.14. So the 0.13 would be responses, proportion of responses. And 0.14 would be the proportion of reinforcers that schedule would earn us. So we have almost perfect matching there. Good to go. We're going to go ahead and do another example just to make sure that it is all clear. Copy and paste my formula just so we don't have to scroll up for it. So in this circumstance, again, we've got these VI schedules. So the first thing we need to do is figure out what the reinforcement rate would be on those schedules. So if you recall, we're going to do that by taking our total 60 minutes per hour, because again, we've got this responses per hour as our unit over here, and divide by 4. So our VI 4-minute schedule is going to earn 15 reinforcers per hour. So next, we're going to do that for this other schedule. So we're going to take our 60 and divide that by 30. 2 reinforcers per hour. So not a ton of reinforcement available on this response option B per hour. Okay, remember that the next step was going to be to solve each side of our equation. So first, I'm going to substitute out those variables. So the response rate for option A was 325 divided by the sum of the response rate for option A and the response rate for option B. Our next step is going to be to complete what's in the parentheses. So 325 plus 42. 367. And then lastly, we're going to actually do that division. So 325 divided by 367 is 0.885, so 89 once we round. So a large proportion of responding is being allocated to response option A. Let's see if that aligns with the reinforcement that's available on option A. Okay, so similar to usual, first step, substitute those variables. So we're looking at the reinforcement rate. So that would be 15 reinforcers that are available per hour on option A, and divide that by the sum of the reinforcement available on option A and B, 15 plus 2. Next, we're going to complete those parentheses. So 15 plus 2 equals 17. And lastly, we're going to do that division. 15 divided by 17 equals 0.882. So again, we've got 0.88 equals 0.89. So we've got some pretty good matching there. Oh, excuse me, I switched those. Although it really doesn't matter which side of the equation as long as you keep straight which one's reinforcement and which one's responses. So 0.89 equals 0.88. The organism is responding a large majority of the responses to this response option A, but that's okay because that's where a large majority of the reinforcement is available as well. Perfect. So we've got down the proportional matching equation when we're working with simple response rates, VI schedules in a really kind of controlled sort of way. When it gets tricky is when you might have variables that reinforcement schedules that differ in other ways. So in addition to the schedule, we also have to think about reinforcer magnitude. So in the Vollmer and Beret study that we read, they used a version of the matching equation called the concatenated matching equation. This is used when there are two reinforcers available that are worth different magnitudes of reinforcement. So in this case, they looked at 3-point shots and 2-point shots in a basketball game. So to do an example like that using the concatenated matching equation, we're going to take a look at that too. Notice that it's written a tiny bit different. I want to draw your attention to a few of the things that look different but really aren't. So in this case, we have it written with the proportional response written over top of the total available responses as opposed to having that slash division mark. So that looks different. It's not different. The other thing that's a little bit different here is that they use R and R in italics, lowercase r in italics. So in this case, our capital R represents response rate, and our lowercase italics R represents reinforcement rate. So another way that you could know that if you were to forget is that the one that has this multiplier right here, the concatenated modification, is the reinforcement rate because the reinforcer is what differs across those two available response options. So just a heads up for that. So for this example, I have drawn data from some basketball statistics. So across the 2019-2020 season, LeBron James attempted 384 3-point shots and made 132 of them. He attempted 1,176 2-point shots and made 588 of them. So we can solve here for how LeBron James allocated his responding and whether that was consistent with the reinforcement that was available for those options. So response option 1 was making a 3-pointer. So we will start there. He attempted 384 3-point shots and he made 132 of them. So recall that the first thing we want to do is calculate the reinforcement rate. So in this case, when we're looking at response rate, we're going to go ahead and use these numbers of 384 and 132. And our unit there would just be per season. That wouldn't be an average across lots of his seasons, but in this particular season, that's our unit. There were 60 games. We could calculate out an average across those 60 games and then use that as our unit. But this is going to be with the fewest manipulations to those data, and it gives us round numbers to work with, which is useful in its own right. So to calculate reinforcement rate, we want to look at how many attempts he made versus how many he scored. So we have 132 completed three-point shots out of a total 384 three-point shots that were attempted. So if you divide 132 by 384, he made the three-point shots on 34% or 0.34 as a proportion of the time. So on 34% of attempts, he made the shot. Okay, we want to do the same thing for the reinforcement rate of 2-pointers. So for 2-pointers, he made 588 shots. So that will be our numerator. And then our denominator out of 1,176. So he made 0.5 or 50% of the 2-point shots that he took. Okay, so now that we have our reinforcement rate and we still have our response rate because it's just those round numbers, we can look at solving our concatenated equation. So I went ahead and wrote it out in a way that was more typical to what we had looked at previously. But similarly, we will solve for 1/2 at a time, just because that's kind of the easiest way to do it. First step, substitute the variables. So remember that our capital R is response rate. So that's going to be the actual numbers of how many he completed. And that'll be the attempts, so 384. Attempts, and that was out of a total attempts of 384, so that same value, R sub 1 again, plus the attempts for our other response option, so 1,176. Step number 2 is going to be to solve the parentheses. So I will do 384 divided by that sum of 384 plus 1,176, which is 1,560. So he made 1,560 total shots, and 384 of those were 3-point shots. We're not going to get into adding free throws to that because that just gets really messy. Now, lastly, we're going to divide what's left. So 384 divided by 1,560 is 0.246, so 0.25. So 25%, or a proportion of 0.25, responses were allocated towards 3-point shots. Now we will solve for the reinforcement that was available for those responses. Step 1, sub the variables. So in this case, our R1, remember our reinforcement rate for 3-pointers was 0.34. And that's going to be divided by the sum of each of these. So 0.34 plus 0.5. Next, we're going to divide Oh, excuse me, we're not going to divide next. We need to complete our parentheses. So we've got 0.34 plus 0.5. Again, probably could have done that in my head. 0.34 divided by 0.84. And then now we're going to divide. 0.34 divided by 0.84. And that equals 0.40. Okay, so let's look at these numbers and talk a little bit about what they mean. So in this case, we have 0.25, a proportion of 0.25 responses were allocated to 3-point shots. Out of the 0.4 was the proportion of reinforcement when weighted. So when accounting for the points that he could have gotten for that, that was the proportion of reinforcement or points that were available for those responses. So this means that LeBron James actually could have scored more points if he had allocated more of his responding towards 3-point shots versus towards 2-point shots. Mind you, some of your colleagues, your classmates and I were talking about the fact that there are other reasons why he probably didn't respond in a way that was strictly allocated to response rate. So yeah, he makes 25% of the shots, excuse me, he makes 40%, 34% of the 3-point shots that he makes, that he takes. However, there are other factors that are available there. So they talked about in the Vollmer paper about how perhaps somebody stops kind of defending that 3-point zone if somebody's never taking 3-point shots, and that makes it more similar to a variable interval schedule. I doubt we're going to get an effect like that with a player like LeBron James. So it's possible that somebody's defending that 3-point zone really hard. There's competing contingencies in place that make that not available, even if he could make most of the shots that he takes from that area. So just interesting to look at. I hope that was helpful.